I'm Harley Smith, and this is the Master Growers course. Today we're going to be doing a presentation on Zero Runoff Technology. If you want to learn how to grow plants, especially in greenhouse environments, you want to look at the Dutch. They're way ahead of us in technology for greenhouses. They're at least 20 years ahead of us in horticulture. They have high-tech greenhouses with zero runoff as the national standard. They collect water and rainwater from the roof, clean it. They add nutrients, specific nutrients through the computer with precision fertilizer management, adding individual minerals according to the plant's need. The computer even changes the recipe that's feeding to the plant at each stage of the plant's growth and modifies it according to the environmental conditions as well. The results, they can cut their fertilizer costs in half or more while increasing yields. They're way above anything that we're getting here in the United States. Also, by doing zero runoff and giving the plant exactly what it needs when it needs it, we can help protect the environment. Runoff is a major environmental hazard. Phosphate runoff. Here in the United States, the farmers add about 5 times more phosphorus to their crops than the plants need because phosphorus gets locked up in the soil. But now the soils are so saturated with phosphorus that in many states, if you even add manure to the ground, you get a heavy rain, it'll wash off into the groundwater, into the lakes, cause bloom of algae, ruin our groundwater and our surface waters. And that's for commercial agriculture. Now in hydroponics, it's a little bit more precise. But here in the United States, generally speaking, we're doing drain to waste. We're giving the nutrients to the plants one time, the nutrients flow over the roots, the plant takes up some of the nutrients, but the rest goes down the drain. It's wasteful, it goes into the environment. Again, it causes environmental hazards. So we need, as a nation, as society, to protect our groundwater, protect our surface waters, and at the same time be efficient in growing plants. Years ago at the Millennial Conference, there was the World Health Organization held a Millennial Conference. And a reporter asked the head of the World Health Organization what he felt was the #1 priority for education in the next century, the next millennium. And his answer was hydroponics. He said, because only through hydroponics are we going to be able to feed the world in an environmentally responsible way. Now, I'd take that one step further. We need to learn how to do recirculating systems with hydroponics, but we also need to learn how to restore the earth by using microorganisms that unlock nutrients from the soil, feed them to the plant. If we do both, we can have the best of both worlds. We can improve the nutritional value of our food, we can grow more food with fewer resources, and we can all benefit from health benefits. Okay, now, how do we do this? How do we achieve that as a goal, zero runoff? I've been in the hydroponics industry now for over 20 years, working with hobbyists and with commercial growers. Now, a hobbyist can do something very simple. They can just use a grow formula and a bloom formula. They start with the grow formula during the vegetative grow stage. Then at the fruiting and flowering stage, they take out the grow and put in a bloom formula with more phosphorus and potassium. If they use a recirculating system, they only have to change the reservoir maybe once every week to 10 days. Now, I've worked with kids setting up hydroponics labs in schools, and one way we conserved, we got one step closer to zero runoff, is the days that they had to change the reservoir, the kids would bring in water jugs from home. They take all the wastewater from their hydro system and fill up the jugs and then take them home to their moms. And the mothers would use it to water and to fertigate the houseplants. Well, the next thing you know, the moms are saying, "Can you get me some more of that plant water? My plants have never looked so good." The reason why is in the hydroponics, All of the essential elements were there, including trace elements that may be missing from the soils. So instead of just pouring it down the drain, which is drained to waste, they were taking it home. Now, some of these students were young entrepreneurs too. They learned about supply and demand. They said, "Sure, Mom, I can get you some more of that water for a 50-cent a gallon donation to our program, to our science program." Moms would say, "Sure, here's $1, bring me 2 gallons home." Well, if you do the math, 1 gallon of concentrated nutrient solution makes 200 gallons of full-strength nutrient. They could make enough money selling the wastewater to replace all their nutrients with fresh nutrients for the plant and still make a profit. Now, as commercial growers, we couldn't do that because any fertilizer has to have an NPK ratio. And after it goes over the roots of the plants 2 or 3 times or more in a recirculating system, we don't know exactly what's left in the nutrients unless we do a nutrient analysis because we have to put an NPK ratio. So in a greenhouse, selling the wastewater, probably not viable. But we can put back in what the plant takes out. And the way we do that is, first of all, doing a water analysis to find out what's in the raw water, and then build the hydroponic nutrient around it. I make custom nutrient formulas for commercial growers, customized to their crop, to their stage of development, to their growing medium, to their water. Now that's the first thing a commercial grower would do. Would take a water sample from their well or water source, send it to a lab for an irrigation water analysis. That water is run through an ICP mass spectrometer. And the grower gets a list, right down to the parts per million, of all the minerals that are in the water. How much nitrogen or phosphorus, potassium, what's the pH, how much bicarbonates, how much calcium and magnesium especially. Once you know what's in there, we can build the nutrient around the water. There's some commercial growers I've worked with over the years that had so much calcium and magnesium and sulfur in their raw water that I made custom nutrients with 0 calcium, 0 magnesium, and 0 sulfur because there was enough nutrition in the water alone. All we had to do was unlock it from the water. And in that case, we did a little switch for pH development so we could unlock the calcium and magnesium. Instead of using phosphoric acid to lower pH, we used nitric acid. It was a nitrogen source. Plants take up lots of nitrogen, but it helped with the quality of the raw water. When you have calcium carbonate, you have magnesium carbonate in the raw water, which you know from your water analysis. If you add a little bit of phosphoric acid, the phosphoric acid burns off the bicarbonates as carbon dioxide in water, but then it reacts with the calcium to make calcium phosphate. That's what your bones are made out of, 95% insoluble. And if that calcium is insoluble, it's unavailable to the plant. So it falls out of solution like snowflakes, and it causes limescale. But we switch to nitric acid with the commercial grower. The nitric acid still burns off the bicarbonates as carbon dioxide in water, but then it reacts with the calcium to make calcium nitrate. That's 98% water soluble. So if we can unlock the stored calcium, if I have to add more to it for a custom nutrient, I'll just add calcium nitrate. It's fertilizer for the plants. So I turned insoluble calcium into soluble calcium that plants can take up to strengthen the plants. So that was one big step towards zero runoff, utilizing the minerals that are already in the water. The next step with the raw water was to build in a pH buffer. Now, if you use something like rainwater, collecting rainwater from the roof, that's a great thing. The Dutch do that. They collect the rainwater from the roof. They even have rain sensors on the tops of their greenhouses that when it starts to rain, the sensor senses it, closes the vents for the greenhouse so it doesn't drip on the crops, And then it sets off a timer so that the water starts to wash off the dust and dirt from the roof for about 10 minutes. Then it starts to collect the rainwater. And that rainwater is very soft, and it replaces the water that plants transpire. So it's a good source of nice, clean, soft water. But because it's so soft, the rainwater has no buffer for pH. The pH can vary and very dramatically at different stages of the plant's growth. You have the same thing if you're using RO water, filtered water. It's nice and clean water, but the pH doesn't buffer. So I build a pH buffer. Here's a little science for the day. If I use a weak acid plus the salt of a weak acid, combine them in the right proportions, it builds in buffering capacity for the water. So if I have real soft water and I want to add nutrients, I can add a phosphate buffer to add my phosphorus to it. Dipotassium phosphate, monopotassium phosphate, so that it's locked in. I can lock it in right at the pH that is best for the plants. So if I build that into the water, I'm closer to zero runoff because I'm adding, now I've unlocked calcium, but I've also added the phosphorus and some of the potassium that the plant needs. One step further to making a customized nutrients. Okay, so we've started with the raw water, utilizing the minerals that are in there, added a pH buffer, so we've added other minerals to the water now. Then comes the rest of the essential elements. So we always start out with calcium. We talked about that with calcium nitrate, compensating for the calcium that's already in the water. So now I've added all the calcium that plants need and some of the nitrogen. The next step is to add more nitrogen so that we have the right parts per million for the needs of the plant, the right recipe. We'll add that as potassium nitrate. Now I've finished off all the nitrogen and given the plant some of the potassium, but I need more. So I'll add a little bit more potassium as monopotassium phosphate. Now I meet all of the phosphorus needs of the plant and most of the potassium. If I want to fine-tune that, I can add some other sources of potassium, potassium chloride or potassium sulfate. So you see what I'm doing? I'm starting to build the nutrient around the water one step at a time, giving it exactly what the plant needs. So as they pull it out, I can just replace those individual mineral salts, just like they do in the Netherlands. Once we have all the potassium and the phosphorus, I add all the trace elements, the magnesium first, as magnesium sulfate. Now, if there's lots of sulfur in the water, well, I add more sulfate. So then I would adjust the magnesium form to better suit the source water. We build a custom nutrient that use the least amount of fertilizers for the biggest effect on plant growth and yield. Okay, next, in the zero runoff situation, we've created our base nutrient, our main recipe with all of the essential elements now in the proper balance. But we have to keep it in balance because plants are going to be pulling out some nutrients and leaving some behind. So that's where we do a nutrient analysis. In the Netherlands, they capture all of the wastewater. And then once a week, they'll take a sample, send it to the lab, run it again through an ICP mass spectrometer. They get a readout of all the minerals that are left in the water that the plant didn't take up. They enter that information into a spreadsheet, and the computer tells them how much of each individual mineral salt to put in to replace what the plant took out. Nothing goes down the drain, and they're only adding the nutrients that the plant needs. At the end, you're harvesting plants, you're adding water, and you're adding nutrients, protecting the environment and maximizing the efficiency of your grow. But in the process of adding one individual mineral at a time and reusing the water over and over again, it has to be cleaned. Over time, there's root exudates, there could be fungi, there could be pythium, there could be viruses even that start to accumulate over time in your water because there's some organics that are exuded from the roots. So to compensate for pathogens, clean the water. Conventionally, the Dutch will use ultraviolet sterilization. They run the nutrient solution through UV, a UVC generator. It kills any of the bacteria that's accumulating in the raw water, so they can use it over and over and over again, and just top off with clean rainwater. Now, one of the downsides of UV sterilization is that it can tend to oxidize some of the metals. It'll oxidize the iron and the manganese, for example. And if it oxidizes, it becomes unavailable to the plant. And it could also start to create films on the UV sterilization. So one of the new methods for cleaning the water are biofilters. My wife, Sue, she set up one of the most prestigious hydroponic teaching greenhouses in the United States years ago with zero runoff technology, with the weather stations on the roof, with the Dutch computer controls. And she had one of the very first biofilters in the United States. And what that does is it uses natural biology to clean the water at room temperature. They have lava grains in a filter, pump in oxygen to turn them over, and then dose with a very small amount of organic biostimulants. We'll talk more about those and the effect it has on plants. But in the biofilter, it stimulates the metabolism of the microorganisms that in nature clean the water. They're already there. They stimulate the metabolism. They're able to clean the water completely in 2 minutes as the water runs through. And the microorganisms actually make iron and manganese more available to the plant because they make organic acids and enzymes to unlock the iron and help the plant take it up. So not only did they eliminate the electrical costs of sterilizing the water, but they made nutrients even more available using nature. Another benefit of the biofilter, it even breaks viruses in the water. Usually you'd have to pasteurize the water with a lot of temperature to kill viruses in the water. Some viruses like tomato mosaic virus can devastate a crop, and growers go through extensive steps to eliminate or prevent that. But with a biofilter, the microorganisms make enzymes, digestive enzymes. One of those enzymes is called a protease. It breaks down proteins into amino acids. Viruses have a protein coat. So if you can digest the protein coat, it deactivates the viruses so it can't spread. So it's even eliminating viruses to zero. So the extra oxygen, the microorganisms are reducing E. coli to zero, the root rots like Pythium and Rhizoctonia to zero, and even some of the viruses to zero. Very exciting technology, and it works with very low maintenance using nature as our guide. The last step in zero runoff technology is leaf analysis. Now, some nutrients accumulate in the leaf tissue over time. Others are depleted over time. Now, if we just add the fertilizers, over time some might be taken out of the nutrient solution, but if we put them all back in, it could be giving it too much to the plant because they take it up so quickly it accumulates in the leaf tissue. For example, if you overdo it with phosphorus, you keep adding phosphorus over and over again, it can start to build up in the tissue. A phosphorus toxicity will show up as a zinc deficiency. So once a week, take a leaf sample, or at different periods during the growth of the plant, take some leaf samples from your crop, send it to the lab. They'll process it, run it through the mass spectrometer, get a readout of all the minerals that are in the leaf. So now we can compare the minerals that are in the nutrient solution that we created to the minerals that are accumulated in the leaf. If phosphorus is starting to build up into luxury levels, it's simple. You just reduce the amount of phosphorus that you're putting in your nutrient solution. If the zinc is going to low levels or deficient levels, we can play detective. We could either reduce the phosphorus or we could add a little foliar spray with the zinc that it needs just on the leaves. We can give the plant exactly what they need when they need it before you see results or symptoms of a nutrient deficiency. that means that we're going to be able to help the plant reach its true genetic potential. If we see a problem, if we see iron deficiency, or if we see phosphorus deficiency, it's too late. It takes time for the plant to reacclimate and recover. But if we can see it starting to build up or starting to come down, we can fine-tune our nutrients and get one step closer to zero runoff. If we do all these things, we will be able to improve the nutritional value of food, improve the medicinal value of our medicinal herbs. It's key and crucial that we provide the optimal levels of iron and manganese for the plant to make key medicinal compounds and some of our favorite medicinal herbs. We need to see that before there's a chance for the deficiency. Be proactive. Zero runoff technology gives us that tool to do that. If we do see a deficiency, we see yellow leaves, what is it? Is it an iron deficiency? Is it nitrogen? Is it magnesium? If we don't know for sure, we only guess unless we send a leaf for analysis at the lab. And then we'll know for sure. To measure is to know. And the best growers are the best record keepers. The data that we get from the lab will help us make better decisions in fertilizing, better decisions for maximizing quality and maximizing yield. I hope you enjoyed today's presentation on zero runoff technology. Please apply what you've learned, get better results, and I hope to see you in future classes.